Okay, good morning class. At this point you received your question papers. We're going to go now through the memo of this paper. If there's anything I haven't marked, please indicate it by circling the question number in pencil. Okay, if there's a missed mark and the mark must be given to you, don't jump up and scowl. You will get it. Okay, I don't get paid extra if I don't give you the mark. Okay, alright. Let's go. So yes, the paper was for 50 marks for 1 hour. Right, let's go. The first question says, put this there. It says you are given that p is equal to 2x plus 5 into the root of 7 minus x minus 7 over x minus 5. The question says for which values of x is in 1.1.1 p equal to 0. P will be equal to 0 if and only if the numerator is equal to 0. So in other words, it's going to be 2x plus 5 times the root of x minus 7 is equal to 0, each factor equal to 0. So x is equal to negative 5 over 2, or that the root of x minus 7 is equal to 0, square both sides. So x equal to 7, 1 on each there. In 1.2, the question says where it's imaginary. When will it be imaginary? If under the root is negative. So it's x minus 7 is less than 0, which means negative, so x is less than 7. 1 on that answer then. If it had said undefined, which it didn't, the answer would have been x is equal to 5. So the denominator would be equal to 0 then. The next one, it says simplify without using a calculator and showing all steps. Firstly, there's a plus or minus between it, so I must break up and factorize. So that's going to be 3 times 5 to the x times 5 to the negative 1 plus 2 times 5 to the x 5 squared over 3 times 5, x times 5, 1 minus 4 times 5 to the x. What do we do now? We take out a common factor of 5 to the x. People, that is never going to cancel that. Okay? Why? Because there's a plus or minus between it. Okay? So 5x is the common factor. So it's going to be 5x into 3 times 5 to the negative 1 plus 2 times 5 squared all over 3 times 5 to the 1 minus 4 times 5 to the x. Of course that cancels. Leaves you with 3 over 5 plus 5 squared is 25 times 2 is 50. No? Over, is that correct? Yes? Over 15 minus 4. Okay, 15 minus 4 of course is 11. That's going to give me 253 over 5. Okay? So it's 253 over 55. Is that correct? Now it simplifies into, I think it was 23 over 5. Let's check. 253 over 5 divided by 11. 23 over 5. You all agree with that? Right. Just let me know if I'm going wrong. Eh? Can you do that? Yes, sir. Right. So let's carry on here, people. 10 can be broken up into 2 times 5. X minus 2 times 9 is 3 squared raised to the x over 5 times 3, or 3 times 5, to the x times 2 times 3 raised to x minus 1. So this can be written as 2 to the x minus 2 times 5 to the x minus 2 times 3 to the 2x as a multiply of exponents. 5 to the x, 3 to the x times 2, x minus 1 times 3x minus 1. When I'm dividing and bases are the same, what do you do to the exponents? Subtract when you're dividing. Okay? So that base and that base are the same, so only those exponents gets brought together, and only those exponents again gets brought together. Okay, you all agree with that? Right. So let's go. It's going to be 2x minus 2 minus x plus 1 times 5 x minus 2 minus x times 3 2x, there's a x minus x plus 1. So it's 2, that cancels, it's negative 1, multiplied by 5, that cancels, minus 2 times 3, that cancels, leaves you with 1 there. As you can see, it has a negative exponent, so I must bring it down. So that's going to be 1, the 3 to the 1 stays on top, 2 2 times 5 squared. 5 squared is 25 times 2 is 50. So it's 3 over 50. Okay. Let's carry on. The next one is number 1.2.3. As we know that x squared doesn't go all the way down, is 1 over x squared minus 1 over y squared all over 1 over x plus 1 over y. What's your LCM in the numerator? X squared, y squared. So this was multiplied by y squared, that was multiplied by x squared. So you got y squared minus x squared must be divided by. Where am I getting the divide line sign from? D. Okay? It's divided by what? Where LCM here is xy. So this must be multiplied by y, and this by x. So it will be y plus x. Okay, we're going to change this to multiplication, we tumble and times. We're going to take the difference of 2 squares there. As you can see, it will be able to cancel. So y minus x, y plus x, all over x squared, y squared times x over xy over y plus x. So y plus x cancels y plus x cancels one of those, y cancels with one of those there. So it's y minus x over xy. Okay. The next one, 1.2.4. The first step in simplifying is to write the largest perfect square, which can go into 48, which is 16. Is that correct? 16 times 3 plus 3 times 25 times 3 plus 2 root something times 3, which is, I think it was 49 in this case. No? So it's the root of 3. The root of 16 is 4 root 3 plus the root of 25 is 5 times that 3 is of course 15. Yes? Yep, absolutely. Supposed to have been minus here. Why? Because that was minus. No? Thank you. Plus that 7 that's coming from here times 2 is 14 root 3. So as you can see inside the brackets it's like terms. So that's going to give you minus root 3. So it's 3 root 3. So it's going to be 3 times root 3 times root 3 is 3, which gives you an answer. Okay. Any issues here? Sorry about that once again, and thank you to that person. In each of the following, rationalize the denominator. As you can see here, what is making this irrational is that square root of 5. So I say root 5 over root 5. So 10 times root 5 is 10 root 5 over root 5 times root 5 is 5 times 3. Of course, 5 goes into 10 twice, into 5 once. So it's going to be 2 root 5 over 3. Okay. The next one, we're moving too fast. Yes? Okay, now we'll move a bit slower, so we'll stay probably break. So what must this be multiplied by? 2 root 5. And what do we call that? The conjugate pair. Okay. Why? Because the result will give us an answer of difference of 2 squared. Okay. People, this is just a memo. We have done the work on this already. So it's not about explaining everything again. But for you, I'll do it, okay? 2 root 5 times 2 root 5 is of course 4 times 5 minus 4 times 4 is 16. So it's going to be 12 into 2 root 5 minus 4. What is 4 times 5? 20. Nice. And what is 20 minus 16? 4. So it's 12 into 2 root 5 minus 4 over 4. People, that 4 and that 4 will never cancel. Okay? Why? Because it's the plus or minus between it. However, 4 goes into 4 once, 4 goes into 12, 3 times. So I multiply that in there, which is now going to give me 6 root 5 minus. Okay. Now some of you will say, hey, but I got that answer. Right? But you crooked yourself in getting that answer. Okay, use the calculator. Alright? Again, when we mark this here, this question we check for this step. Okay. So watch out for that. People in question 2, 2.1, it says solve for x. So this is your exponential equation, not so. So the idea is to get the basis the same for the exponents to be. For the exponents to be equal, yes. Alright, so there's 525 can be written as 5 squared raised to the x equals 5 cubed. So it's going to give you 5 to the 2x is equal to 5 cubed. Therefore, the bases are the same, exponents are equal. So 2x is equal to 3 divided by 2, x is equal to 3 over 2. Okay. There you go. Yes, as if that's the one you got right. Of the whole question too. Right. People, this one here. Don't multiply this out if it's already equal to 0. It's already factorized for you. Now you multiply it out, you get some other Mickey Mouse. And then you try and factorize it and you get further away from the truth. Okay, you use half a page and 20 minutes of your time. Okay. People, 2 factors. The 0 factor rule, 3x minus 1 is equal to 0. Or 2x minus 1 over 27 is equal to 0. They get over the equal sign, so 3x is equal to 1. So 3x is equal to 3 to the 0. Therefore, x is equal to 1. Oh, you say not 1. Nice. Right, you take that over, becomes 3 to the 2x is equal to 1 over 27. So 3 to the 2x, 27 can be written as 3 cubed. 3 to the 2x, you take it up, becomes 3 to the minus 3. Therefore, 2x is equal to minus 3 divided by 2. So x is equal to negative 3. Okay. The next one is the case substitution here. So as we can see that x to the half can be written as x to the quarter squared plus x to the quarter minus 12 is equal to 0. So what do we say? Let k equal x to the quarter. I got that. This will be k squared plus k minus 12 is equal to 0. So trinomial. So you got k and k, 4 and 3, plus and minus. Not so. What do we say here? K plus 4 is equal to 0, k is negative 4, or k minus 3 is equal to 0, k is equal to. People, if you couldn't have worked this out, we could have used the quadratic formula. Then you go straight into this solution here. No? You don't have to force it into the brackets and then you get some other nonsense solution. Okay. People, what is k? X to the quarter is equal to negative 4, or x to the quarter is equal to 3. To get rid of the quarter, I raise it to the power of 4 both sides. So on this side, x is equal to 81. However, even the denominator's number must be positive, so no solution on that one. Right, you guys understand? This is where you lost your mark there? Where did you lose your mark? 2.2. That's the first point you lost the mark on. Huh? Nice. Okay. You will see where you lost the mark. So the first thing here is we need to isolate the x. Not so. So it's going to be a root of 2 minus 7x equal to x minus 2. So what do I do now? Get rid of the brackets. We square both sides. Not so. So that cancels and that's what I want. So it's 2 minus 7x is equal to first term squared, x squared minus 4x plus 4. People, if you can't do that, write it out twice, multiply that. Don't keep yourself brave. Okay? We will just, the marker will think there's something wrong with you, but it's fine. As long as you get some right. Okay? So, If you don't know the binomial square root, it's fine, you multiply it. So 0 is equal to x squared minus 4x plus 7x is plus 3x. 4 minus 2 is 2. So that's going to give us x plus x and 1. Not so. Both is plus. So we say x is equal to negative 2 or x is equal to negative 1. But what do I need to do here? I need to check. Yes. So what I do is I put negative 2 into the side of the equal sign. You should give me an answer of negative 2. So if I put negative 2 in here, it's going to be 14. Plus 2 is 16. The square root of 16 is 4, and 4 plus 2 is 6. So that one doesn't work. Not so. Now we go with the other one. Okay, again, we substitute negative 1 in here. So it's going to be negative 7 times negative 1 is 7, plus 2 is 9, the square root of 9 is 3, and 3 plus 2 is 5, but x is minus 1. So there's no solution to the sum. What? Oh, no. Okay. Remember, there's going to be times where both are solutions, where one is solution, and this is the case where none, of course, is the solution. 2.2 is where you lost all 3 marks. Huh? Yes. This is the only point you lost the mark. Huh? 1.1.2. 1.1.2. Imaginary? No, are you going to lose a mark again there in your control test? It'll come up again in your control test. These questions are going to come up again and again. June exam, final exam, comes up over and over. So for those of you who are not working and you're failing, you're going to be tested on the same stuff, you're failing again and again and again. Okay. So have a talk with yourself and let me know what you have chosen. You're going to work harder or you need help or whatever, tell me. We'll sort you out. Alright, 25 can be written as 5 squared raised to the x plus 0.5. So let's get rid of the brackets. So that's going to give us 5 to the 2x plus 1. Not so. Which also can be written as 5 to the 2x times 5 to the 1. However, 5 to the x is 10. So, 5 to the x raised to the 2 times 5. Not so? But what is 5x? 10. So 10 squared times 5, which is 100 times 5 is 500. I think Jordan did a beautiful calculation. She used logs. And she got 500 out. But how much marks out of 3 did she get? 0. Why? Because it says without solving for x. And she solved for x. Okay. A beautiful calculation. If that wasn't there, I had to give you 3 marks. But I made sure that was there. Right. Given x squared minus 2x plus 6. Write the given trinomial in the form of a into p plus x all squared or x plus p all squared plus q. So we must complete the square. So there's a 1 in front, so that's in order. So x squared minus 2x plus a number minus the same number plus 6. So what's the number in this case? It's going to be b times, oh yeah, I forgot I'm very fast, square. So what's b in this case? No, 2. 2 times half? 1. 1 squared is perfect square trinomial. So that's going to give us x minus 1 squared minus 1 plus 6 is 5. Alright. Next question. It says determine the maximum or minimum value, stating where there's maximum minimum. So this is plus, so it's going to be a smiling graph. So it will have a minimum value of 5. Give the value of x to which the expression will have a minimum or maximum value. X is equal to 1. Where's the additive inverse on your x? Okay. (3.2). The width of a rectangle is x. You got the rectangle, the width is x, and the length is 20 minus x. Calculate the dimensions if the area is a maximum. How do we calculate the area? Length times breadth. It's going to be the area, not so. So the area is going to be x into 20 minus x, which is negative x squared plus 20x. Okay. So, what we do with this is now we're going to complete the square. So a is equal to minus x squared minus 20x. Not so. So we go a is equal to minus x squared minus 20x plus a number minus that same number. And what's the number in this case? Going to be b times r squared. And what's 10 times r? 20 times r? 10. And 10 squared is 100. So again, there's my perfect square trinomial. So it's negative into x minus 10 squared minus 100. So it's negative into x minus 10 squared plus 100. Okay. The question is the dimensions. So what's the dimensions? The x and y, or the length and the breadth. So your breadth is going to be x, which is 10, and your length is going to be 20 minus 10, which is 10. So it's a 10 meter by 10 meter, or units, whatever. Okay. Will you guys understand? You will get another one like that in your exam, since you understand now. You control this. People, the bonus question in Layan, I don't know. Nobody figured Layan out. No? Nobody could help Layan. We are told that the sum of the digits of 51,820 is 5, that I'm getting from here, 1, the 8, the 2, and the 0. It's all coming from. And 5 plus 1 plus 8 plus 2 plus 0 is 16. Leon thinks that the sum of the digits of 5, 1 to 6 times 3 to the 3 times 7 times 2, 1 to 4 is also 16. It's not. Yes, but you won't get a mark for saying it's not. Okay? So what I note here is that that is 2 to the 124, that is 2, that's 5 to the 126. There's some link that's happening between it. So what that says, 5, 124 times 5 squared. So that makes 5, 126, not so. Times 3 cubed times 7 times 2, 124. Let's say, hang on. 2 to the 124 times 5 to the 124 can be written as 2 times 5 to the 124, which is 10, 124. Say, okay, Layan is on the road here, she's getting somewhere. 5 squared, of course, is 25 times 27 times 7. Okay. So 5, so that story there is going to give us 25 times 27 times 7. So that gives us 4,725. So 4,725 times 10 to the 124. Now, if it was 4,725 times 10 to the 1, then that would be 4,725. Oh, not so. If it's times 10 to the 2, it's 4,725 double up. Times 10 to the 5 is 4,725. 1, 2, 3, 4, 5. Not so. So even if it's times 10 to the 1 to 4, so it's 4,725, 124 zeros, which makes no difference. Why? Because 4 plus 7 plus 2 plus 5 plus 1 0, 2 zeros, 5 zeros, or 124 zeros is the same. So in other words, that will give us 4 and 7 is 11, 16, 18. That's where your 2 marks are. Okay. So, only 2 marks? Imagine I gave you 10 marks on this. You would have lost 10 marks. So don't think only 2 marks. Be grateful it was 2 marks. People, that's it. If there's any problems with my marking, please bring it to me now, okay?